Okay, so today we'll be solving the problem number B of AtCoder Beginner Contest 43. So let us open the problem. So the name of the problem is unhappy hacking. So let us read the problem statement. So Sig has built his own keyboard designed for ultimate simplicity. This keyboard only has three keys on it: the 0 key, the 1 key, and the backspace key. To begin with, he is using a plain text editor with this keyboard. The editor always displays one string, possibly empty. Just after the editor is launched, this string is empty. Okay, so by default, the string will be empty on the editor. When each key on the keyboard is pressed, the following changes occur to the string. The 0 key is pressed, then a letter 0 will be inserted to the right of the string, that is at the end of the string. Similarly for the 1 key and the backspace key, if the string is empty, nothing happens. Otherwise, the rightmost character of the string is deleted. Okay. So Sig has launched the editor and pressed these keys several times. He was given a string S. It is a record of his keystrokes in order. Okay. In this string, the letter 0 stands for the 0 key, the letter 1 stands for the 1 key, and the letter B stands for the backspace key. What string is displayed in the editor now? Okay. So the constraints of S are from 1 to 10. That is the length. There is a number of operations that the person Sig has performed are at max 10. And what I need to output is the string that will be present on the editor at the very end. So there are several approaches to this. So first, let's discuss the brute force approach for this question. So in the brute force approach, what we can do is we can read the input string, that is that is what operations that Sig has performed, and we can say if the operation is 0, then I will go into my current string present on the editor, and I will say concatenate a 0 at the end of that string. Similarly, I will do for 1. If it is a 1, then concatenate 1 at the end of the string, and if it is a B, then I need to discard the last character. So what I can do is I can take a substring of the current string which omits the last character. So this can be the brute force approach for solving this problem. So let us go into the editor, and the input that we will be given is a string. So I will come here. I will take the string as input. So let me say fr.next, and since we are dealing with strings and we need to access the ith character of the string, so since in Java I cannot use the array notation to access the ith character, but since I really like that notation, I'm going to convert this string into a character array, which is pretty easy to do by using the inbuilt function of toChar array. So that gives me a character array corresponding to the given string S. Okay, so now let us take a variable to know the length of the string S, which is array.length. And now I need a string to store the final result. So I will call that as string answer is equal to this. And then I'm going to process these operations one by one. So I will run a loop over this string. And as I mentioned, I will check if the current character is a 0. All I need to do is add a 0 at the very end. So it will be answer plus 0. And if the given character is a 1, I can just add a 1 at the end of the string. Otherwise, if it is not a 0 or 1, I'm sure that this given character is a B. That is, the user has pressed the backspace key, in which case I need to omit the last character. So how can I do that is, I can say answer.substring, which is a function present in the string library, string class and itself in Java. It also present in majority of the programming languages. So it takes in a beginning index, which will be, since I'm going to take a substring and I only need to discard the last character of this given string, I will be taking the string from the very beginning, but I need to omit the last character. So the ending index will not be the first of all, let me explain how the substring function works in Java. So it takes two parameters. First is the beginning index, and the second is the ending index. And it returns a string that goes from the beginning index up to the ending index minus 1. That is, the ending index is exclusive. We do not include the ending index in the string. So what I can do is I can use the length parameter to get the length, and the last index will be at this n minus 1. So if I take from 0 to n minus 1, so what I will get is a string running from 0 to n minus 2 because the last character is exclusive. And I can just set my string to that. But there is a catch in this. That catch is if the length of the string currently, that is the string answer, is 0, that is I do not have anything in it, this function will be from 0 to minus 1. And that will give an error because the indexes cannot be negative. So we need to take that into account. So I'm just going to say if answer is empty, I need not do anything, so I can just continue. Otherwise, if the answer is not empty, then I will do this operation. So after all the operations are done, I can just print whatever I get. So I will just do that and then I can run this. So, and let me take the input that is given here itself. I can come here and I can check that what is the output that we get for the given input. And the output is 0, 0, which is right. So let us take the second test case. Now in this test case, if you see we are using 0 and then we are using 2 backspaces. So at one point the string will have been empty. So if we had not put this check here, we would have got a runtime error. So we are getting an output of 1, which is the right output. So let us just paste this code here itself. I'm going to copy this, I'm going to paste it here. I'm going to change the name of the class to main since the file will be saved as main.extension, and then I'm going to hit on submit. So this is the brute force approach for this question. So let us see if this works or not. As we can see that this answer has been accepted by the judge, but this answer is not the most optimal answer, and there are many optimizations that we can do. The first of all being, this is a language specific answer, that is string operations in Java, especially the concatenation operation, is very time consuming. So Java cannot concatenate two strings together and keep the same string object because strings in Java are immutable. So what Java does is that it creates a new string object and then it adds the value of these two strings and then returns that new string as the output when we do the concatenation operation. And also the substring operation takes a big O of n time because it loops through the beginning to the end and then it returns the string that it gets as a result of all the characters present in that range. So we are having several places to optimize in this code. So I'm not gonna be doing the string specific operation because that is language specific, which can be handled by using the classes like string builder, which offer mutable strings and that can run very fast. But I will not be doing that to keep this video simple. The main operation that I need to optimize is to avoid using this substring function. Now, why did we use this substring function? It was because we wanted to remove the last character from the string. Now, if you are familiar with the concept of stack, that is a data structure which allows us to insert and remove values from one end, this operation can be done using a stack in big of one time. Now, what do I mean by that? So, what is a stack is, if you can imagine a pile of CDs kept on a CD holder, if you have ever seen, or not, if you can see a pile of books. So, if I place a book on top of that pile, it will be at the very top. And if I try to relate that with this problem, let us consider this input that is 0, 1, B, 0. So what I'm doing is I'm saying that place this 0 at the very end of the string. So if my string is currently this, I want the programmer to place 0 at the very end. And similarly I will do for the 1. So it's not like I'm going to place 1 here or somewhere else. It's at the very end of the string. So that is we are inserting elements from one end. I will repeat. Whenever we are inserting something into our current string, we are doing that from a given end. That end is not changing, and since it's fixed, that is, it is only going to be happening from one end. One condition for using a stack is fulfilled, since stack also allows insertion only from one end. Now, whenever I'm having a backspace, I need to remove the character that I inserted just before this backspace. So just before this backspace, I inserted a 1. I need to delete that. So if I see, I'm deleting the character from the very end where I was inserting it. That is, I'm inserting and deleting the characters from the same end. I will repeat, I'm inserting, that is whenever I inserted the 0 and 1, it was from the very right end of the string, and I'm also deleting the characters from the right end of the string. So this is the second condition for using a stack is also fulfilled. That is, insertion and deletion are happening from the same end. So now this becomes a very good candidate for using a stack. So I will do the same. I will create a stack which will store characters because 0, 1 and because 0, 1 are characters itself. So I can create a stack for that. Stack. Let me call it as st and I will create a new stack of type character itself. And what I can do is that whenever I get a 0, I will say insert a 0 into my stack. And whenever I get a 1, insert a 1 into my stack. Now what would be the replacement for this condition? This was the condition to use to handle whenever the string was empty. So in our case, what we can say, if we have already removed all the books from our pile and we are still trying to remove any book, then that is the case that is equivalent to this. That is, when I'm trying to remove a book from the pile when there are no books. So in that case, what we can say that whenever our stack is empty and we are trying to remove something from it, that is the case that corresponds to this condition. So what I can write this as, if the stack is empty, that is, we do not have anything in the stack, in that case we cannot remove anything from that stack. So that is how we can do that. And if I want to remove the last element from the stack, I can use this stack.pop operation. So this is going to give me a stack that contains all the characters in the way that I want. So if I consider 0, 1, B, 0, what would happen is that my stack will contain a 0, then I will insert a 1, then the backspace will remove this 1, then I will insert a 0. And what I can do is I can loop over the stack and I can concatenate whatever I have here and get the answer. Now I'm going to take another case here. So let's say I have something like 00B1. In this case, what I will do is I will insert the first 0 into my stack and the next 0 into my stack, and then the backspace will remove this 0, and then in the next operation I will insert a 1 into my stack. Now since insertion and deletion happen from the same end in the stack, when I am removing elements from the stack, the first element that I will get is a 1, because first this element will get removed, and once that element has been removed, the next element that I would get is a 0. So I can see if I were to add these elements like 1, the first element that I got, and then a 0, the output that I will get is 1 0, whereas the original output is meant to be 0 1. That is the reverse of this. Now, this is not an issue with using stack, this is the property of the stack. So there is a very easy way to handle this, and that is that whenever we are removing the characters from the stack, let us say I removed a 1, so I will add that to my answer, which is initially empty, so it does not seem like much. But when I remove a 0 from the stack, what I can do is since I am trying to reverse the output, I can say is that do not do this plus 0, because this is the usual way of adding strings. That will keep the string in the original order, but we want to reverse it. So what we will do is we will say first take a 0 and then add the answer. So that will give us 0 plus 1, that will give us a 0 1, which is also the way we want the answer to be. So now what we can do is we can take a string answer and we can say while the stack is not empty, do answer is equal to whatever we get from the stack plus the answer, so that we get the reversed answer. So now this is also going to work. So let me just quickly come here, run this, give the same inputs, that is 0 1 B0, and we can see we are getting the same answer. I'm also going to give the second input, that is 0 BB1, still it works. So let me just copy this code from here, take it over here, paste it here, go to the very top, replace it with main, submit it, and we can see this is also accepted. So now what is the difference between this approach and the previous approach? So in the previous approach, the main issue that we were having was when we were trying to delete the last character because it was taking big of n time. But as I just mentioned that removing the last character from a stack is a constant time operation. So we just optimize that big of n operation to a big of one operation. So the previous code would have had a time complexity of big of n square. Not usually n square, but it can be upper bounded by n square, and which will not work if the constraints are up to, let's say, 10 raised to the power 5 or 10 raised to the power 6. But this approach here using stack, it performs that substring operation that we were doing earlier. It performs an alternative operation to that in the constant time. So now the time complexity for this approach is big of n. So that is why using this approach is better than the previous one. So that is it for this video. And if you have any doubts regarding how I implemented this or any questions as to why am I using a stack here, kindly ask them in the comment section. And if you like this video, make sure to subscribe and hit the like button. And I will see you in the next video. Thank you.